Great to see you here. My name is Luc de Ceuster, founder of the Ceuster Academy, and I'm here to present to you a new video from our Math Survival Guide. In this video, we will talk about polynomials, again, division of polynomials, and we are looking at some special cases so that you understand better how certain principles work. But before we start, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look. First, we have to consider two polynomials. We have the first polynomial, which is of the second order, 2x to the square plus 11x plus 15. And then we have the second polynomial, x squared minus 9. Both are of the second order, but it's not really important here. You will see what we will conclude at the end of this exercise. Now, what we have to do is we are looking at the division of a divided by b. And when we look at that, we find that it's 2x to the square plus 11x plus 15 divided by x squared minus 9. And of course, we have to look at the conditions. And the conditions here say that x squared minus 9, which is the denominator, should not be equal to 0. So basically from this we can say that x squared minus 9, when you look at the special product formulas, can be written as x plus 3 times x minus 3, and it should not be 0. So basically either of these terms cannot be equal to 0. From this we can say that x cannot be equal to plus or minus 3. Now when we look at the next step, we have to factorize the numerator. We already factorized the denominator, but now we have to look also, let's say, what we do with the numerator. We still have our expression. We have 2x squared plus 11x plus 15 divided by x plus 3 times x minus 3. And now we see that we can write 2x to the square plus 11x plus 15 as a product of 2x plus a multiplied with x plus b. We know that we have the first coefficient is equal to 2 because we have 2x to the square. And when we expand this, we find 2x to the square plus 2bx plus ax plus ab. And basically we can rewrite this in a simpler format, saying 2x to the square plus 2b plus a times x plus ab. In this 11x or 11 is 2b plus a, and 15 is equal to a times b. So basically we get results out of that. 2b plus a is equal to 11 and ab is equal to 15. Now we are going to use this formula, we're going to use this information to find the values of a and b. And basically what we can do is we can use what we described before as the method of trial and error. So basically we have two equations, 2b plus a is equal to 11 and a times b is 15. There are different ways to resolve this. We can say a is 11 minus 2b and we bring that in ab and we find another equation, but we will have to resolve another quadratic equation. So we are looking for a different way of resolving that. When we look at a and we have the product of a and b, we can have a equal to 1, 3, 5 and 15. And when we have that, when a is equal to 1, in order to have the product of a and b equal to 15, b has to be equal to 15. So we have 1 and 15, 3 and 5, 5 and 3, and 15 and 1, which are in fact possible values for a and b. Now we have to see what is the value of 2b plus a when we have those numbers a and b. So when we start with the first one, we can say this is 2 times 15 plus 1 is equal to 31. It's not equal to 11. So that's not a valid combination. We have 3 and 5. So we have 2 times 5 plus 3 is 10 plus 3 is 13. It's also not a valid solution. and we go to the next possibility, 2 times 3 plus 5. This is equal to 11, and basically that's what we want. So we find that A is equal to 5 and B is equal to 3. So we found now the different terms, and we can rewrite this expression. We can factorize this expression. And we find for the expression 2x to the square plus 11x plus 15 is 2x plus a times x plus b. We know a is 5, b is 3, so finally we find 2x plus 5 times x plus 3. And now we can bring all that information back into our division, and we find in the numerator, we find 2x plus 5 times x plus 3 divided by x plus 3 times x minus 3. And we see that we have two parameters which are equal, so x plus 3 in the numerator and in the denominator, So we can simplify this, and finally we find that the division gives us 2x plus 5 divided by x minus 3. And that's the final result of this division. Now we have to look at the conditions, and when we look at the condition here, we see that x minus 3, that's the only expression in the denominator, cannot be equal to 0, so we have to say that x cannot be equal to 3. Now, when we look back at the original, we also have to keep the second condition, because we started from the original equation, and in the original equation we had x plus 3 and x minus 3 in the denominator. So basically it means that x cannot be equal to minus 3. So we have that result here that we have to keep the original conditions. But let's have a look at something else. Let's look at this expression here. We have c is 2x plus 5 and d is x minus 3. We find the quotient c divided by d. We have 2x plus 5 divided by x minus 3. This is the same result than what we had before. Now, the conditions here are in fact that x minus 3 cannot be equal to 0, so x cannot be equal to 3, which is basically the only condition in this case. This may be a little bit strange because we basically find the same result, but the conditions are different. Now, when we look at the comparison of those two divisions, we had the first one, 2x squared plus 11x plus 15 divided by x squared minus 9, where we found as a final result 2x plus 3 divided by x minus 3. And we have q1, 2x plus 5 divided by x minus 3. So basically the result is exactly the same. Now for this expression, for the first one, we have the two conditions. X cannot be equal to plus or minus 3. On the other hand, when we look at the second division, we only have x cannot be equal to 3. And that's basically because we started from that original equation. And when you look at the two formulas, and when you start with the original formula, when you calculate, for example, in Excel, the values of 2x squared plus 11x plus 15, and you do the same for x squared minus 9, and then you do the division, then you will see that there are 2 points where x squared minus 9 is equal to 0 and where we have a division by 0. And those two graphs look totally different because we have a second 0, a second root for the denominator. It is very important when you look at these elements, when you look at these equations, that you take that in mind. You always have to know where do you start from. And those two expressions, they look alike, but basically their starting point is completely different. And we have to take that into account when we are looking at those divisions and at the results and the formulas that we found after the division. It's a very important element to consider. So basically, we have to say the original conditions always count. Although the formulas may look the same, but they were from different starting points, and based on that, there are different rules, different conditions to follow. The original conditions always remain valid, whatever we do with the divisions later on in the calculations, and we will look at some more examples like this. Very important point here, those original conditions, very important, don't ever forget it. Division by zero leads to problems and we have to avoid it. We always have to identify when do we have a division by zero. And that was it for this video, but before leaving, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in the next video. Bye bye.